So we've been looking at Lewis structures for very simple molecules. We can draw Lewis structures for much more complicated molecules. 3 atoms, 4, 5, 10, 173. So we need to learn how to draw Lewis structures. So these are the steps, and they may or may not make any sense, and then we'll do some examples. First step is to write the correct skeletal structure for the molecule. What does that mean? Well, how are the atoms arranged? How are they connected to each other? When you only have 2 atoms, it's pretty simple. They have to be connected to each other. But when you have 3, then you have different possibilities. Which one do you put in the middle? And, you know, if they're all different, which one do you put in the middle and which one do you put on the end? And so there's some guidelines, and some of it just ends up being kind of experiment. Hydrogen atoms are always going to be terminal. A terminal atom is an atom on the end. It's one that's only attached to one other atom. Hydrogen has to be terminal. It only has 1 electron it can share. It can only form 1 bond. Okay, other atoms that have more electrons can form 2 or 3 or 4 or sometimes even more bonds. And so they could be in the middle and be bonded to multiple things. The other thing is, you know, it's like atoms are like children holding hands and crossing the street. You're going to hold on to hydrogen's hand because he's the baby, and you're not going to trust him to hold on to somebody else's hand. So hydrogen only makes 1 bond. Molecules tend to be symmetrical, so that you can use that as a kind of a guiding principle. When you have, say, 1 nitrogen and 3 oxygens, the chances are good the nitrogen's going to be in the middle and the oxygens are going to be around it. But then all of these guidelines have many exceptions, so don't complain. Number 2, we have to figure out how many electrons we have to deal with. How many valence electrons are there between whatever atoms are in our compound? So you look at the valence electrons for each of the atoms and you just add them up. If you have an ion, if it's got a charge on it, if it's a negative ion, it's negative because it has extra electrons. So if you have a -2 charge, then you have to add in 2 electrons. If you have a positive ion, you have to subtract. Then we're going to distribute those electrons around the atoms, trying to make everybody happy. First of all, though, you have to put bonds between all the atoms that are bonded together. Because if there's no bond, then it's not part of the molecule. So you're going to have at least a single bond holding it all together, and then you distribute the rest of them as best you can so that everything has 8 valence electrons, or 2 for hydrogen. Sometimes you don't have enough. You're like, well, I distributed all my dots and there's not enough. Some people are still unhappy. Well, then there needs to be more sharing. If there's not enough cookies, we need to share more, okay? And so then you take some of those non-bonding electrons, those lone pairs, and you bring those in and you share those as well. And you may end up with double bonds or triple bonds. So let's squeeze one example in here before we go. So Lewis structure for carbon monoxide. So the skeletal structure for this is going to be pretty simple because there's only 2 atoms. So it must be carbon next to the oxygen. Now we need to identify how many valence electrons we have. Well, carbon has 4 because it's in group 4, and oxygen has 6 because it's in group 6. And 4 plus 6 is usually 10. So now we're going to take our electrons and start putting them around. We're going to put 2 electrons between carbon and oxygen because there has to be at least a single bond to hold them together, otherwise it's not a molecule. So there's 2, and there's 4, 6, 7, 8, 9, 10. We ran out. So I've got 10 electrons, and I'm trying to share them so that each atom has 8. And it's not working, is it? We can't throw more electrons in there, but we can share more. So what if we took these 2 and shared those as well? Now let's be careful. This carbon has 1, 2, 3, 4, 5, 6, 7. I'm going to use my little magic here to make it easier to look at. So we're going to share those two in there. We still have 2, 4, 6, 8, 10 electrons. Carbon has 2, 4, 6, 7. Oxygen has 2, 4, 6, 7. They're still unhappy. So we need to share more. So let's take these guys out here and move them in here. And share more. Now they each have 8. Okay? So now we're good.
We need to put 3 sticks.
3 sticks, yes. So the other way to represent this is with 3 lines for the triple bond, and then these are lone pairs. So we have 3 bonding pairs in this molecule and 2 lone pairs, 1 on each atom. So I'll see you in lab.